Hello, and welcome to our application training video on an intuitive and innovative feature on all E-Instruments combustion analyzers. As you already know, proper combustion efficiency testing is paramount in knowing exactly how safely and efficiently our equipment is operating, including boilers, furnaces, and heaters. However, what some contractors do not know, or have not been told, is that how combustion efficiency is actually measured and calculated is quite different on older atmospheric systems than it is on newer condensing and high efficiency equipment. This short video will help to explain the differences and the features on all of our analyzers used to measure properly on both systems regardless of what E-Instruments analyzer model you might have. Combustion efficiency is a measurement of how well any given fuel is being burned and converted into useful energy. For example, heat, hot water, steam, etc. These calculations are based on three major factors: the chemistry of the burned fuel, propane, natural gas, oil, whatever it may be, the CO2 percentage by volume after the combustion process, and the net temperature difference between the stack gases and the primary air being used for combustion. For years, we were taught that all analyzers measure the ambient air temperature in the boiler room via a built-in internal temperature sensor, and the thermocouple at the probe tip measures the stack temperature in the flue. Then the analyzer calculates this differential temperature between the two, which is in turn used for the combustion efficiency calculations along with the O2, CO2 measurements, and the fuel type. However, things have changed lately. Newer high-efficiency condensing furnaces, boilers, and tankless water heaters use a different method of measuring the differential temperature because condensing systems use outdoor air as the primary temperature, not the ambient room temperature anymore. This is done either by using a two-pipe system or a concentric vent. Both bring in air from outside for combustion. Furthermore, the stack temperatures of condensing systems are much lower than atmospheric systems, more like 100 degrees Fahrenheit, not 300 degrees Fahrenheit anymore. So the importance of properly measuring the correct delta T is much greater for accurate combustion efficiency calculations using your combustion analyzer. See this example. If we use an analyzer the same way we do on an atmospheric system, then this is what we could see. Here we have 100 degrees Fahrenheit in the stack, minus the ambient air temperature of 80 degrees, gives us a delta T of 20 degrees Fahrenheit. However, this is not necessarily true, because we are actually using cooler outdoor air temperature for primary air for the combustion. In the winter, even much colder outdoor air temperatures. So the actual delta T can be quite different. Here we have 100 degrees in the stack, minus the outdoor air temperature of 20 degrees Fahrenheit, gives us a delta T of 80 degrees Fahrenheit. That's a big difference in measuring the delta T and has an effect on our true combustion efficiency calculations. Most manufacturers of high-efficiency condensing furnaces, boilers, and water heaters these days provide two test ports for proper testing of the incoming air temperature and the stack temperature. So how are analyzers able to test the incoming air temperature simultaneously with the exhaust temperature to measure properly on a condensing high-efficient piece of equipment? E-Instruments has two innovative ways in order to do this. Number one, all of our analyzers have the ability to manually input the outdoor air temperature to override the ambient temperature sensor in the unit. The analyzer then does all of the efficiency calculations based on the temperature you input. More importantly, this information will be on your printout and on any saved data that you might have, along with the time and date. Number two, our analyzers have the ability to add an optional smart incoming air temperature probe to measure both incoming and the exhaust air temperature simultaneously. All of the E-Instruments combustion analyzers have this innovative and popular feature built in for our contractors' needs in the field and what our equipment manufacturers want to see their equipment being installed, serviced, and tested correctly. All of our analyzers are high efficiency ready and one of the first models in the field to have this important feature and capability. You can find out more information on some examples and application notes on our website under the Applications toolbar at www.e-instruments.com. inst.com.